Good morning. Welcome back all my dear students of Primary 6. A new session with Science Syllabus, Unit 1, Force and Motion, Lesson 1, Mass and Weight. Last time, if you remember, we stopped at the meaning of mass, the measuring tools or the measuring devices and measuring units of mass. Today, I'll transfer to the other part of the title. We know that the title of this lesson is Mass and Weight. We talked about all the parts of mass. We studied mass, and now we will transfer to the meaning of weight. But before we talk about the weight, I want you to look at this figure and try to think what may be concluded from this figure. We can see a person. This person is sitting under an apple tree. This person is sitting under an apple tree. Suddenly, an apple is falling down. And this person asked himself, why did the apple fall down? Why did the apple fall downwards the earth? Why didn't it move in any other direction? Why didn't it move in the direction of clouds, for example, or any other direction? This person changed the way we understand the universe. When he asked himself, is there any force attracting the apple downwards to the earth? The answer for his question was a very, very important discovery in the history of science. The reason for the apples falling downwards is a force called gravity. Gravity is a force by which an object is attracted. Gravity is a force by which a body or an object is attracted to the center of the earth. Gravity is the ability of the earth to attract any object on its surface, towards the earth. This scientist, which is a very famous scientist, is called Isaac Newton. Isaac Newton. Newton is the scientist who changed, as I said before, he changed the way we understand the universe with his great discovery, which is called gravity or gravitational force or the weight. So, today we talk about the second part of the lesson, which is called the weight. Can you conclude the meaning of weight? I said the apple fell down. The apple fell down downwards to the earth under the control of the gravity force. The gravity force or the weight or the gravitational force, it is a force by which a body is attracted to the center of the earth, or the ability of the earth to attract the objects towards the surface of the earth. So, the weight is a force by which the body is attracted to the center of the earth, or a force, or the gravitational force by which a body is attracted to the earth. I want to tell you that you can call it as gravitational force, or you can also call it as weight. So, the weight or the gravity or the gravitational force is a force by which the objects are attracted to the earth. As you see here, these are some kids. The kids are jumping up, then they fall down. What attract, or what is the name of the force that attract their body downward? The force that attracts any object on the surface of the earth downward towards the center of the earth is called the gravity or the gravitational force or the weight. This is for the meaning of weight. And I wanted to tell you that some people are confused about the meaning of mass and weight. And I think now we know the difference between them. They are not the same. Mass is the amount of matter in an object, while the weight is a force by which an object is attracted to the earth. Mass is the amount of matter in an object, but the weight is a force by which a body is attracted to the center of the earth or to the center of the moon or any other planet. So, the objects fall downwards the earth. The objects fall down towards the earth due to the gravitational force or the weight or the force which can attract all objects on the surface of the earth to its center. Now to the measuring unit of weight. Do you remember the mass? How many units are used to measure the mass? We have 2 units. For small masses, we use gram. For large masses, we use kilograms. But here, for the weight, we study only 1 unit. Only 1 unit will be studied in our lesson for the weight. The measuring unit of weight is called or named after the great scientist who discovered the gravity. Do you remember his name? In appreciation of his effort, in appreciation of his great discovery, the unit for measuring the weight is called after the great scientist, which is called Isaac Newton. So, the measuring unit of weight is Newton. And it is named after the scientist who discovered the gravity force, and I think it is in appreciation of his effort in the progress of science. And now, my dear students, let's move to another part in our lesson. For mass, we have 4 devices. You remember? For the mass, we have 4 tools or 4 devices can be used for measuring the mass. But here, we talk about the measuring device of weight. The measuring device of weight. Only one device can be used for measuring the weight. Only one device can be used for measuring the weight. The measuring device of weight is called the spring scale. The spring scale. Let's talk more about the structure of the spring scale and the main idea of its working. As you see, this is the spring scale. Here we have a top hook. Through the top hook, we can hang the device. We can hang the device through its top hook. At the end of the spring scale, we have a bottom hook. Through the bottom hook, I can put the object. I can hang the object that I'm going to measure its weight. So, the spring scale is the measuring unit of weight. The spring scale is the measuring unit. Measuring? What is my mistake? I said the spring scale is the measuring unit. Is it a measuring unit? Yes, it is not a measuring unit. It is a measuring device. It is a measuring device or a measuring tool of weight. We use it to measure the weight of objects. It has a top hook. Through the top hook, I can hang the device. At the bottom hook, I can put the object that we are going to measure its weight. Up till now, we don't understand how does it work. I'll tell you. This spring scale has a pointer. As you put the object here, the object will be pulled downward, the earth. The object will be pulled down by the effect of the gravity force. The pointer of the spring scale will move and stop at a certain number here. This spring scale has, we can say it has a graduation, starting from 0, ending with any other number. So, as you hang the object will be pulled downward. The pointer of the spring scale will move and stop at a certain number. For example, if the pointer of the spring scale stopped at 10, what is the unit for weight? Can I say 10 and stop talking? This is not right. And in the science exam, if you write the value of weight equals 10, this is not you will not get the full mark. After the number, you should put the measuring unit. So, if the pointer of the spring scale stopped at number 10, it should be followed by the unit for measuring the weight. So, I should say 10 Newton. 10 Newton. So, the spring scale is the measuring unit. Measuring device of weight. The spring scale is the measuring tool or the measuring device of weight or the device that we use to measure the weight. It has a top hook and bottom hook. At the top hook, we can hang the device. At the bottom hook, I can put the object that we are going to measure its weight. The pointer of the spring scale will move down and stop at a certain number. This number will give the reading, or the reading of the spring scale will give the accurate weight of this object. And for example, if it's 10, it will be 10 Newton, 30 Newton, and so on. So, as a conclusion of what I said before, we have the spring scale, which is the measuring device of weight. Look at this figure. This is a spring scale. And here I have the spring scale, and I'm going to use it. I'm going to use the spring scale in measuring the weight of different masses. In this table, I put the masses that we have. I have a mass of 1 kilogram, 2 kilograms, 3 kilograms, 4, 5, and 6 kilograms. Up till I don't know these numbers. I'm going to use the spring scale. I'm going to use the spring scale to measure the weight for 1 kilogram. A mass of 1 kilogram, if you have a mass of 1 kilogram and you put it here at the bottom hook, the object that has a mass of 1 kilogram will be pulled down, and the pointer will stop at 10 Newton. From the experiment, we concluded that for a mass of 1 kilogram, I have an object, its mass is 1 kilogram. I put it here in the bottom hook. It will be pulled down, and the pointer will stop at 10 Newton. How did you know this number? From the spring scale. Just put the object here, the pointer will be pulled down and stop at a certain number. I just record the number here. I take the number and write it here. So, for a mass or an object of a mass equals 1 kilogram, its weight will be 10 Newton. An object with a mass of 1 kilogram, its weight or the pointer of the spring scale stopped at 10 Newton. For an object whose mass is 2 kilograms, an object whose mass is 2 kilograms, I put it here on the bottom hook. We observed that the pointer of the spring scale stopped at 20 Newton. If we have an object of 3 kilograms, an object whose mass is 3 kilograms, and I put it here, I hang it here to the spring scale, the pointer of the spring scale was pulled downward and stopped at 30 Newton. For another object whose mass is 4 kilograms, it was observed that the pointer stopped at 4 Newton. For another object whose mass is 5 kilograms, I put it here on the bottom hook. What will happen? The object will be pulled downward and the pointer of the spring scale stopped at 50 Newton. And finally, with an object whose mass is 6 kilograms, and as we did before, I just put the object here, I just hang it to the bottom hook, it will be pulled downward due to the effect of gravity force, and the pointer of the spring scale will stop at 60 Newton. The question now, I want all of you to look at this table and tell me, what do you observe? I start with a mass. I started with a mass of 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, 5 kilograms, and finally we stopped at 6 kilograms. We observed that as we increase the mass, or as the mass of an object increases, the weight will increase. As the mass of an object increases, the weight will increase. For a mass of 1 kilogram, the weight was 10. 2 kilograms, the weight was 20 Newton. 3 kilograms, the weight was 30 Newton. And for a mass of 4 kilograms, the pointer of the spring scale stopped at 40 Newton. And finally, or before the end, we have 5 kilograms. The pointer of the spring scale stopped at 50 Newton. And for the last object whose mass is 6 kilograms, the pointer of the spring scale stopped at 60 Newton. Our conclusion, what do we observe? We observe that as the mass increases, the weight increases, and vice versa. When I say vice versa, I mean 6, 5, 4, 3, and so on. The weight will decrease 60, 50, 43, and so on. So, what is the relation between mass and weight? We can see that the relation between mass and weight is called a direct relation. Direct relation. As the mass increases, the weight will increase. Same like when I say, the more you study, the more marks you can get. The greater the mass, the greater will be the weight. As the mass of the object increases, its weight will increase. How did we get these values? Using the device for measuring the weight, which is called the spring scale, and I explained the way or the idea of its working before. So, I start now with the factors affecting weight. The first factor that I have mentioned is the object's mass. And for the relation between mass and weight, we said that as the object's mass increases, the weight increases, and vice versa. Greater mass will be a greater weight. Smaller mass means a smaller weight, as we explained in the table using the spring scale. And finally, I can conclude the relation between mass and weight. But before we conclude the relation between mass and weight, I want you to back to this table. Here we have an object of 1 kilogram as a mass. Its weight was 10 Newton. We can conclude a very important rule here. An object's mass multiplied by 10, an object's mass multiplied by 10 or times 10 will be equal to its weight. For example, 1 multiplied 10 will be 20. 2 multiplied 10 will be 1 kilogram times 10, the weight will be 10 Newton. 2 kilograms times 10, the weight will be 20. 3 multiplied by 10 or 3 times 10, it will be 30 and so on. So, we can conclude the mathematical relation between mass and weight as follows. The weight on the earth for any object will be equal to its mass multiplied 10. Its mass times 10. So, here we have a very easy question. Let's start with this problem. The mass of a person is equal to 70 kilograms. The mass of a person is equal to 70 kilograms. Calculate his weight. So I should say his weight. Sorry, I'm so sorry for this. So, if the mass of a person is 70 kilograms, calculate his weight on the Earth's surface. The rule that we apply here is the weight of the Earth equals mass multiplied 10 or mass times 10. And the value of mass is given here in the form of kilograms. Before you answer this question, you should be sure that the mass is given in the form of kilograms. If it is not given as kilograms, you have to change it before you answer. So, the weight on the Earth, the mass is already given as kilograms. So, I can put the rule, I can write my rule and apply it in one step. So, here we have the weight on the Earth equals mass multiplied 10, and the mass is already given here. So, it will be 70 multiplied 10. The net result here, or the final result, will be 700 Newton. Don't forget to write the unit before you end your answer, because you may waste some of your marks if you forget writing the unit for measuring the weight. Another question here. Calculate the weight of an object on the Earth's surface if you know that its mass equals 500 grams. I told you that before we answer the question, we should be sure that the mass is measured or given in the form of kilograms. But here I have a problem. You have the value of mass given as grams. Before you answer, you should change it from grams into kilograms. And we all know that to change from grams into kilograms, this value should be divided by 1000. So, step 1, you will write mass equals 500 grams divided by 1000. So, the value of mass will be 0.5 kilograms. Now you can apply the rule that we know. Weight on the Earth equals mass multiplied 10. Mass is already measured in kilograms. So, it will be 0.5 multiplied 10, it will be 5 Newton. Now, it's your time to test yourself. Calculate the weight of an object on the Earth's surface if you know that its mass equals 30 kilograms. Before we answer this question or this problem, you should ask yourself, the value of mass is given in the form of grams or kilograms. As you see, it's 30 kilograms. So you can answer this question in only one step. Write the rule that we usually apply in this problem. The weight on the Earth equals mass multiplied by 10 or mass times 10. It will be 30 multiplied 10. So the final answer here will be 300 Newton. This is for you to test yourself. I just tell you the oral answer for this question. Thanks for watching. See you later in other videos.